Welcome to Brain Vision.
All right, so we're told to use f equals negative du over dx in the book. This is on page 187, negative du over dx. And so du over dx is the slope. So that would be the opposite of the slope. All right, so at A, the slope is 0, so the force is 0. At B, the slope is negative, so the force is positive. At C, the slope is 0, so the force is 0. At D, the slope is positive, so the force is negative. And at E, I'm not sure I drew that well enough to tell. So let me get to the actual problem in the book. E looks like the slope is 0. So 0. All right. Now, we are told that unstable equilibrium is when the potential energy is maximum. So I see that point A is the maximum and point E is a local maximum. And so I'm listing both of those as unstable. Stable equilibrium is when potential energy is a minimum, and that's obviously at C. Neutral equilibrium would be a horizontal line, a period that is horizontal for a little distance. I don't see any of that in this graph, so nothing is labeled as neutral. Finally, we're supposed to graph the force versus x. So that would be the slope of the line versus x. I'm going to make a little room here by erasing this, which I didn't even need to write anyway. So I'm going to put this right below the graph, at least as well as I can. I think I'm going to erase this too. And this and this and this. A lot of erasing. So I can put this right below the graph. So this is going to be force in newtons. So we said that the force is 0 at A and at C and at E. Now, the slope is maximum in magnitude when the slope is greatest. And it looks to me like the slope is greatest where it crosses the x-axis. Now, initially, we have a negative slope, which would be a positive force. So the maximum positive force would be right about in here. The maximum negative force, and the slope looks, I guess the slope's a little bit less. The maximum negative force would be right in here somewhere, but it would be slightly lower in magnitude. kind of like that. So let me look at exactly what we're supposed to be doing again. Sketch. So I don't need it. I don't know if I need to put numbers on here. The slope would be the derivative. Let's go ahead and put numbers on here. I'm going to use points here and here to approximate the slope in that region. So it looks to me like the point above is 2, 1. And the point below here is 3, -1. So my slope is going to be y2 minus y1 over x2 minus x1 so -1 minus 1, 3 minus 1. It's going to be -2 over 2, which is -1. So the opposite of the slope is going to be +1. So I'm saying that this maximum right here is about at 1 Newton. The minimum force, I said the slope doesn't look quite as large in magnitude, so that's going to be a little bit less than -1 Newton. All right, now let's think about the shape of this graph. So the slope is close to 0 here. Whoops. And it's maximum here, but the slope changes gradually. So we don't see an abrupt change in slope. So the curve would look something like this. Now, I went to extra effort of finding an equation of this line and then taking the derivative of that equation. And what I found is that everything here is correct except for the fact that my estimate of slope, which was right here, was not very good. When I took the derivative, I actually got here, it's actually close to 2.2. So this is close to 2.2. And then down here is close to 2, -2 newtons. And I actually do see why. The reason is that 3 minus 1 is not correct. It's 3 minus 2, which would give us 1, which would give us the negative 2. By the way, when I fit an equation to it, my actual equation was y equals negative 0.0157 x to the fourth power plus 3014 x to the third power minus 1.5282 x to the second power plus 0.6864 x plus 3.9, and then the opposite derivative looks like this. I figured this out using a spreadsheet and a curve fit on a spreadsheet. Okay, so that's it.